electric field at any point of short electric dipole. Now see, this is one dipole of charges minus q and plus q. This is short dipole. You know, two positions for the dipole. This is called axial line, this is called equatorial line. Now we are not finding electric field either on axial line or on equatorial line. Somewhere in between there is point, that is called general point or any point. This general point at a distance r from center of dipole and making an angle theta with the axis of dipole. Now breathe in. This is step number 1. What is the topic? We are finding electric field at any point or general point of short dipole. Now for this, in the previous lectures, you learned for short dipole, what is the electric field on the axis of dipole? See, this is short dipole minus q plus q. This is the axial line or end-on position of the dipole. Now what is the electric field at a distance r on axial line from center of dipole at a distance r? What is the electric field? Magnitude of electric field at any point P on the axis of dipole given by the formula 2kP by r cube, where r is the distance of the axial point from center of the dipole. Breathe in. As well as in the previous lectures, you learned it is in the same direction of dipole moment vector. See, dipole moment vector is from minus q to plus q. This is p vector from minus q to plus q. On the axial point, electric field direction is always parallel to, in the same direction of dipole moment vector. So if it is from left to right, it is also from left to right. So this is point number 1, concept 1 for this particular derivation. Point number 2, what about equatorial point for the short dipole? See, this is minus q plus q. This is equatorial point or broad-on position or equatorial line, like this axial line, this is equatorial line. Now we are concerned about electric field at any point P at a distance r, again from the center of short dipole. This is short dipole we are talking about. Then the answer is half of this. Electric field at any equatorial point is half of this, called Kp by r cube. And what is the direction? Electric field on axial line is parallel to dipole moment vector in the same direction. And on the equatorial point, it is in the opposite direction of p vector. See, minus q2 plus q. This is the direction of dipole moment vector. Now on the equatorial line, answer is electric field direction, answer is opposite to that. This is electric field on equatorial point. Breathe in. These two concepts are required for this particular part, derivation or numerical. Now see, given dipole is this minus q plus q. So minus q2 plus q, this is the direction of dipole moment vector from minus q2 plus q. This is p vector. See, this is our question. This is our dipole moment vector. And we know these two concepts on the axial line and on the equatorial line. Now what to do? Focus on the question. I am making it with red color. This is our question. This is our considered point. So draw one line parallel to this given question line and another line perpendicular to that. See the red color. This line is parallel to our given question axis and another line is perpendicular to that. Focus on these two lines. Now resolve this P vector, given dipole moment vector, into two components. First and second. See, any vector having two components, left side, right side. Keep attention in the direction. Focus on direction. So this is one direction and this is another direction. Focus. I am making it like this. See, this is original P vector. Writing here. This original P vector having two components, 1 and 2. So this is P1 vector and this is P2 vector. Just focus on them. P1 vector, P2 vector. Breathe in slowly and gradually. Now as per component concept, you know this P1 will be P cos theta and this P2 will be P sin theta. This you know already. Now this is like, you know, one dipole of dipole moment P vector is split into two different dipoles of two different dipole moments P1 and P2. Like in the previous lectures we learned how to find equivalent dipole moment of two dipoles. Now in this we are making one dipole as two dipoles by component concept. Now breathe in. Step number 2 for this. Now focus only on P1 vector. Forget about question, forget about other lines. Just focus on this line. You will see this first dipole moment vector is behaving like axial point. See, wherever the direction of P vector, in the same direction it will create electric field. This is P1 vector is the first dipole moment vector which is along the axis of this point P. So it will create electric field in the same direction of P1 vector. So this is E1 vector and it is on axial line. So we are writing E1 vector AX for the axial notation. So in the second point you will say this E1x magnitude, I am writing in magnitude, it will be this one. It will be following axial formula. So you will write it like this, 2kP by RQ. Remember, if it is P, you write P. If it is P1, you will write P1. And you know, P1 is P cos theta. So this is 2kP cos theta by RQ. Breathe in again. Direction is known to you. Wherever direction of P1 vector is given, on the axial point electric field also exists in the same direction. This concept 1. Now focus on this line, second line, this one. Focus on this P2 vector. Now forget about P vector, forget about P1. Just focus on this P2 vector line and the concerned point. So you will see this is another dipole of dipole moment P2 vector and this point existing on the broad-on equatorial line. See, equatorial point like this. So first of all see the direction. Electric field on equatorial line is in opposite direction of P vector. This is P2 vector like this. So direction over there will be opposite to P2 vector. Focus on this P2 vector, then it will be visible. This is the direction of electric field due to P2 vector, and since it is equatorial point for P2, we write Now breathe in. See, this red one is E1 axial. We are writing it here somewhat little bit here. E1 AX. This is our concerned point, right? So this is E2 vector. This is equatorial point. See this and this P2 vector. For first P1, see this E1. Now how to write the answer? From equatorial point, point number 3. This E2 will be Kp by Rq, and you know this is P2, so you write P2, and P2 is P sine theta. Now you see these two vectors are perpendicular to each other. So we will apply parallelogram law. As per parallelogram law, when two vectors are given inclined at an angle of 90 degrees, they are joined from tail to tail. So you know theta is 90 degrees. Then their resultant magnitude, that is net electric field at any point, its magnitude will be under the root a square plus b square plus 2ab cos 90. You know cos 90 is 0. So you will write it like this: E1 square plus E2 square plus 2ab cos 90. You know cos 90 is 0. Just write this. And the most important point, resultant of these two vectors will lie somewhere in between. Resultant or net. Now this was point number 4. Now see point number 5. Where it lies? Let us say it is making an angle of alpha with even vector. So you know simple tan alpha on the simple triangle rule. Triangle rule, how to find tan alpha? That is perpendicular upon base E2 E axial upon E1, or E2 equatorial upon E1 axial. Now what to do? Input the values of E1 axial as well as E2 equatorial in both the equation. In this, in the fourth point, and here in the fifth point, you can solve it. Breathe in. Now see numericals on the same. If you know these two concepts which are written now, you are able to solve this derivation as well as so many numericals. Like you are given this question. Two dipoles. Of course, this is the condition. These are short dipoles. Minus q plus q. These are two dipoles given like this. And the question is find electric field, resultant electric field or net electric field at P for these two dipoles. Then you will apply these two concepts. You are going to check whether electric field direction is in same direction of P vector, that is called axial line, or whether it is on equatorial line. See again, breathe in. Now see these are two dipoles. Let us say this one is first dipole. Now focus on this dipole. Then you will see for this red one dipole, first dipole, this point existing on equatorial line. So electric field at P because of first dipole should be following this formula, equatorial formula, that is EP equatorial, half of this Kp by Rq. This is Kp by Rq. Now the point is this R. R is the distance of equatorial point or axial point from center of the dipole. So this should be R. Then you can apply this. Then what about direction? Direction is opposite, anti-parallel to P vector. See minus q2 plus q, this is the direction. So it will be like this. Electric field at P because of first dipole. This is first dipole. Focus, first dipole and this point on equatorial point of first dipole. Then follow equatorial concept. Breathe in. Since these are identical dipoles given to you, so dipole moment of first, dipole moment of second is given P. Identical dipoles are given. Then no need to write P1, P2, or otherwise you should write K P1 upon RQ. And of course P1 is given P. Then again you write Kp by RQ. Because so many times you may be given different dipoles. Breathe in. Now focus on second dipole. Second dipole is this. I am making it black. In the black color. Minus q plus q. This is second dipole. Minus q2 plus q. See, this is P2 vector. Earlier minus q2 plus q. It was P1 vector. It was P1 vector. Focus. Now, see this second dipole. For second dipole, this point lies on axial line. See, axis of the dipole. So, for axial point, electric field is in same direction of P vector. So, P vector is in upward direction, that is P2. So, electric field also in the upward direction at P because of 2. And the magnitude will be K P2 by R cube. Now, P2 is again P, identical dipoles. So, Kp by R cube. Now, you see, these two vectors are perpendicular to each other. Now, from parallelogram law, you may write resultant answer, net answer, your magnitude of net electric field at P for these two identical dipoles under the root EP1 square plus EP2 square plus 2 EP1 EP2 cos 90. Now focus, why we are applying parallelogram law? Because electric field is vector quantity. You have learned in previous lectures. I am reminding you, this is EP1 vector plus EP2. It is like resultant, it is like A vector EP1 and EP2 is like B vector. Now where the direction will lie? You know it. Again, it will lie somewhere in between. This is the direction of resultant or net electric field at P. Similarly, in the previous topic, it is at an angle alpha. So you will write direction directly. Tan alpha is perpendicular upon base. Directly you may write it for these numericals where angle is 90 degrees. EP1 by EP2. Remember, the line makes an angle alpha called base of the triangle. And tan alpha is perpendicular upon base. Got it?